In this lesson, we're going to talk about stacks and queues. At the end, you should be able to explain the behavior of a stack and queue. You should be able to explain the push, pop, and peek methods as they apply to the data structures, and you should be prepared to implement a stack and queue in Java and use it to solve problems. Before we dive into the details, let's just talk in a broad sense about what a stack and a queue is. First of all, stacks and queues are a type of list. Just like an array is a list, an array list is a list, and a linked list is a type of list. However, stacks and queues have special rules for adding and removing. With arrays and array lists and linked lists, generally speaking, you can add anywhere you want, at the beginning, at the end, in the middle. But with stacks and queues, there are special rules that restrict that. With stacks and queues, adding is called a push, remove is called a pop, so a little bit different terminology. And basically these rules limit the way that adding and removing can happen, which makes implementation actually much simpler than doing a linked list. And it turns out that there's just certain types of problems that lend themselves to being solved with either a stack or a queue. Let's start with a queue. Suppose 4 students print their essays to that printer shown on the right. My question to you is this: which essay will come out of the printer first? And you don't have to think too hard to know the answer. Really, whichever student clicks print first, well, theirs will be the first essay that comes out of the printer. It's just like a line at the store. If you get in line to buy something and you're the first person in line, you're going to end up paying first and being the first person out of line. If you're the last person to get in the line, you are going to be the last person to get out of the line. In fact, in the UK, lines at stores are actually called queues. With a normal list, you can add and remove at any spot. Add at the back, add at the front, add in the middle, it doesn't matter. But a queue works just like a line at the store, and so it's a little more restrictive. If you want to add to the queue, you have to add from the back. Just like when you go to check out at the store, you have to start at the back of the line. And when you want to remove from the queue, you have to remove from the front. Now remember, when we add to a queue, that's called pushing, or some textbooks will call it enqueuing, as in entering the line, entering the queue. And then removing is called pop, or dequeue, removing from the line. And so a queue is what we know as a first in, first out data structure. Sometimes that's pronounced FIFO. So if a queue is a first in, first out data structure, then what's a stack? Well, suppose that you've got a pile of homework papers and you want to grab one. Now, which one are you going to grab first? I suppose it could be any one, but generally speaking, when you grab something from a pile, you usually grab from the top. So the last one you put on the pile is the first one to come out of the pile. And so a stack of papers really helps illustrate the idea of what a stack is as a data structure. Again, with a normal list, array list, etc., you can add and remove at any spot. With a queue, you have to add to the back and remove from the front. With a stack, you must add to the top and remove from the top. It works just like a stack of papers or a stack of books or a stack of anything, really. And this is what we would call a LIFO, or a last in, first out data structure. So everything works from the top. Now, stacks also have another method, another operation typically called peek. And peek allows you to look at the top element without removing it. If you've done a lot of Java classes, we might know that as a getter method. So I can add to the top, I can remove from the top, push and pop, or I can peek, take a look at what element is on the top of the stack. Let's do a quick understanding check and see if the general idea of how a queue and stack work is making sense. So on the right-hand side of the screen, I've got some instructions, some pushes and some pops. And what I'd like you to do is I would like you to add and remove from your data structure and determine what's left in that data structure at the end. So for number 1, we'll pretend those operations are on a stack, and for number 2, we'll pretend those operations are on a queue. Go ahead, pause the video, try it out, and then we'll check our answers. If the data structure is a stack, then after doing those operations, we should have the letters T and E left. T would be on the top and E would be right below it. And if the data structure was a queue, then the letters left would be T and S being at the front of the line and T being at the back. Now that we have a basic understanding of how a queue and a stack work, the question then becomes, how could we implement such a thing in Java? And the answer is you really have a lot of choices provided you follow the adding and removing rules of a stack and a queue. For example, you could take the linked list class that we made and modify it, tweak the add method. So for example, for a stack, it only adds to the top and only removes from the top. Or for a queue, make it so it only adds at one end and removes from the other. But you don't have to use a linked list. You could actually make a new class, and that class could contain an array list, and you could define push and pop methods to add and remove based on the stack and queue rules. The truth is, it doesn't matter how you do it, provided that you follow first in, first out for a queue or last in, first out for a stack. If you're implementing a queue, for sure there's going to be 3 methods you need to have, and possibly you could have more, but these 3 would be at a minimum. You're going to need a constructor that creates a new empty queue. You're going to have a push method. You could also call it enqueue if you wanted to. And that's simply going to add a value to the back of the queue. And you're going to need a pop method that removes. You could also call that dequeue. Notice that my methods, I wrote them as generics. So if you're not sure what a Java generic is, you can take a look at the previous lesson on Java generics. But these are the 3 methods you'll need to have at a minimum if you are implementing a queue. If you want to implement a stack in Java, there's a minimum of 4 methods that you are going to need. Again, it's possible you might have more, but generally speaking, these are the 4. You'll need a constructor that creates a new empty stack. You will need a push method that will add a value, a parameter, to the top of the stack. You will have a pop method that both removes and typically returns the top element. So it removes it and returns it. And finally, and this one's different than a queue doesn't have this method typically, you'll have a peek method that returns the top element without removing it. It's possible that a queue could have a peek method. When I talk about, with a queue, you need at least those 3 methods. Again, it's possible you might have more. Maybe for your application, you need or want a peek method, and that's absolutely okay. At this point, you should be able to explain the behavior of the stack and queue data structures. You should also be able to explain how add and remove works with push, pop, and peek. And finally, you should be prepared to implement a stack and queue in Java and use it to solve problems.